Hi everyone. I want to show this time a tool that I developed recently. It is a tool inspired in the PCA, Portland Cement Association manual for concrete slabs on grade. So I want to first explain the mechanism by which we calculate the thickness of the slab on grade. We have to take several steps. This time we want to calculate the slab thickness for a two-wheel or four-wheel loader or a four-wheel elevator. So we are assuming that our elevator has four wheels, like it is shown in this graph, right? So we have a problem here in the moment at the time we want to calculate the slab thickness, because when we want to calculate the slab thickness for a slab on grade, we have to enter with a stress per kilonewton axle, and this variable assumes that the axle has only two wheels, so it's a simple axle. And in our prior case, we have four wheels, so we have to transform this axle load into a simple axle load. And in doing that, we have to assume a slab thickness. And that's the beginning of some mistakes we can make in order to calculate the slab thickness, because we have to iterate many times assuming a slab thickness until we we convert in only one value of slab thickness. So we have to obtain slab thickness assuming another value, and there must be a convergence. So the difference between the assumed value and the last value should be very, very small. Well, while doing that, we have to use many nomographs like this one for four-wheel elevator. And also, in case our elevator has wheels with spacing that is less than 645, effective contact area of the wheels that is less than 645 square centimeters, then we have to also correct this contact area. This effective contact area we have to correct. And again, we have to assume a slab thickness. So we have to assume two times a slab thickness that may be different than the final one, this one. So this kind of calculation is very difficult, because we have to iterate many times. We have to assume the slab thickness. It's getting complicated, right? So in order to avoid this kind of iterations, we developed this tool that is based on system dynamics. And this tool uses the same variables for axle load, and wheel spacing, and all the variables that we see in the Portland Cement Association manual for concrete slabs on grade. We used exactly the same variables. And at first, as you can see here, we assume an initial value, for example, of 250 millimeters of slab thickness. And then we calculate, we have these nomographs that you have seen here. We have these nomographs as predictive models that are already put here. They have been calibrated, taking many points. So we are pretty confident of the estimated values. Have also measured the error between the estimated values and observed values. And we have 3 predictive models for the 3 nomographs that you have seen here. This first one, this second one, and finally the third one. So it's pretty much easier to know the estimated values of respectively the slab thickness, the new load factor, and finally the new contact area. Okay, so we have these estimated values, and it's much easier than solving graphically with the nomographs. Then we can use these relations and these predictive models in our system dynamics model. That is one kind of paradigm of simulation. And then we calculate with these relations the slab thickness. We compare what is the error of the actual calculated slab thickness and the assumed slab thickness. And then in the other iteration, the next iteration, we take this calculated value and we iterate many times until the slab thickness stabilizes or get still in around one value, as you can see here in the behavior over time chart, right? Likewise, we have the same system dynamic simulation model here in Benzene. Here are all the variables, as you can see, and we can play the simulation over right and graph the slab thickness. As you can see, we started with around 250, and then the value stabilizes around 330 millimeters. Okay, so that is the tool. It's very easy to apply. It really makes much easier to calculate slab thickness, considering that we do not have to graphically calculate with the nomographs, iterating many times, maybe making mistakes. So we avoid that mistakes by using this simulation model. Well, thank you very much, and you can contact me if you want to get the tool. Bye-bye.